All right, so let's look at practical applications of linear graphs. In other words, using linear graphs to model real life applications or other things. Okay, so that's what we use the linear graphs for. It's to help us predict things that might happen in real life. So there's a few skills here. So finding a linear rule from a table of values. So you've been given a table of values and you need to find that linear rule. So let's look here. I've got the x values, I have the y values. Now, looking at my x values, I have x equals to 0 and I have the y value for that. So that remembering that the y-intercept occurs when x equals to 0. So straight off we have our y-intercept at y equals -5. Yes, that's 0, -5. So when we're thinking about our y equals mx plus c, well, I've got my c, don't I, which is -5, like that. Now I have to think about the m part, the gradient, the slope. All right, so how do I do that? I can look at these. These are all coordinate points. And we remember that our gradient equals rise over run, y2 minus y1 over x2 minus x1. And do that. Now, a lot of you have probably already guessed the gradient because the x is rising by only one unit each time, and you can see that the y is going up by a certain amount of units each time. You can see that the y is going up by 6 each time, isn't it? As x is going up by 1, y is going up by 6. But I'll also do this as well. So I'll just pick, let's just pick these points here. So m equals 13 minus 7 over 3 minus 2. So m equals 6 over 1. Therefore, my linear rule is y equals 6x minus 5. Now, here's another table of values. Now this time we don't have our y-intercept like we did here because we've got the x is equal to 0. So we'll have to, from our partial equation, work it out. So remember, we always start with our y equals mx plus c. All right, so first off, let's work out this m. Now, x is going up by 1 each step. So how much is y going up or down by in each step? We can see as x goes up by 1, y goes down by 3. So that means our gradient must be equal to -3. So far we've got y equals -3x plus c. So now I've got to figure out the c, the y-intercept. So let's, substituting one of these points, we can substitute in any point we like. Let's sub in that point. So I'll sub in 3, -1. So that implies that -1 is equal to -3 times by the x value, which is 3, plus c. So -1 equals -3 times by 3 is -9 plus c. So now I have to add 9 to both sides. So that gives me 8 equals c. Therefore, y equals -3x plus 8. Now here in my table of values, because the x was going up by 1, I could very easily see that the rise or fall of y was consistent, was the same each step. So I could from that just gather my gradient of m equals -3. But if x wasn't consistent there, then you'd have to do rise over run to find the gradient. So let's start looking at modeling linear relationships. So this is where we have a real life situation. So real life. And we use, a model of a linear rule to really model what's going on. Why do we want to do that? It's good to predict what's going to happen in the future. And that's really why we do these things. It's for prediction. Okay. Prediction. Now, we don't get given what is x and what is y. Sometimes we don't even get given coefficients like pronumerals to use. But here we have, but you should, from the context of the question, be able to work out what is your x, what is your y. Because when you think about your Cartesian plane, okay, so because this is a real life model, we really just have this sort of the positive x and the positive y. Because, in real life, there's rarely negatives. I want you to think about, what would go along that x and what would go along that y. Now, sometimes what gets on the x is called the independent variable. You've probably heard that phrase in science. And the y is the dependent variable. Okay. And in further maths, in general maths, we also use the phrase explanatory variable, and the y is the response variable. Now, all of that means is that as x changes, y changes in response to it. Okay? X changes independently of what is happening with y, but y changes due to a changing x. Okay, it's independent, that x. So the x explains why there's a change happening. Okay, so usually, here's a hint, time will go down the bottom most of the time. All right, so let's look at these examples. So we've got Nathan's bank balance has increased in a linear manner since he started his part-time job. So his bank balance, so we're talking about his savings. If after 20 weeks of work, his bank balance was at $560, and after 21 weeks of work, it was at $585, find the rule that relates the size of his bank balance, A, and the time he worked, T. So if we're thinking about it in terms of the Cartesian plane, this XY gradient axis, A would be our Y variable, our dependent variable, and T would be our independent variable, our explanatory variable. Because, obviously, the more weeks he works, the more his bank balance goes up. It's not that, his bank balance goes up, therefore the time he works goes up. It's the other way around, isn't it? It's because he's increased the amount of time he's worked, his bank balance is going to go up. So we can look at this. All right, so this gives me 2 coordinate points. First coordinate point is 20 and 560. The second coordinate point is 21 and 585. So there are our coordinate points here. So you can see we've gone up 1 week, so our X value has changed by 1 unit. Our Y value has changed also. It's gone up by 15. So Y equals 15t plus C, if we're thinking about that. Y equals mx plus C, which we always do. All right, now we've got to think about that C. What would his bank balance be? We can't assume it's 0 because he might have some money in there. His grandma might give him money. So, how do we figure out what that bank balance is at the start? We substitute in one of these coordinate points. Let's substitute that one in. It's got nice round numbers. So subbing 560. I'm going to run out of room. So 560 equals 15 times by 20 plus C. So 560 equals 15 times 20. So 15 times 2 is 30. So that would be 300 plus C. So I'll subtract 300 from both sides. So that's 260 equals C. Therefore, the rule that links them is A equals to 15t plus 260. So this is saying that when t equals 0, when he started work, he already had $260 in his account. Each week that he works, he increases his bank balance by $15, and A is the amount he has in this bank. So this is how we would read this. A is the amount of money he has in his bank. It's increasing by $15 per week, and he started with $260 in his account. So find the amount in his account after 200 weeks. So we're being told that t equals 200. So I better sub in t equals 200 into the equation, times by 200, 260. Okay, so 15 times 2 is 30. So that'll be 3 equals 3,000, wouldn't it? Plus 260 equals 3,260. So then I extract that piece of information, and this is when I then put in my dollar sign. I wouldn't bother with dollars until at the end. Okay, and we need to find the initial amount. Now, initial means starting amount, i.e. when t equals 0. So that means the starting amount is $260. So here we get told the cost of producing a shoe increases as the size of shoe increases. So that's the piece of information that tells us which is the y and which is the x. So that cost, which we get told here, that cost and shoe size. So the cost of producing a shoe increases as the size of shoe increases. So that tells us there's a positive relationship. It's a positive gradient. As the cost of as the size of shoe increases, the cost of producing the shoe increases. It makes sense, doesn't it? If you try to flip it the other way, as the cost of shoe increases, does the size of the shoe increase? No, the cost doesn't cause the change of shoe size, does it? But it makes sense that the change of shoe size causes a change in that cost, because you think, you need more materials, things like that. So it costs $5.30 to produce a size 6 shoe and $6.40 to produce a size 8 shoe. So assuming that a linear relationship exists, determine the rule, find the rule relating cost to shoe size. So again, we get given 2 points here, don't we? So size 6, $5.30, and size 8 is $6.40. Okay, now that hasn't gone up one shoe size, so I'll find the gradient. So our gradient is y2 minus y1 over x2 minus x1. So that is $6.40, take $5.30 over 8, take 6. Notice that I've taken out the dollar signs. I'm still keeping it to 2 decimal places though, but I'm taking out the dollar sign because we don't need that for our mathematical workings. So you can use a calculator to help you out here. But that $6.40 take away $5.30 is $1.10 over 8 take 6 is 2. I'm sure you can then say, well, that is 55 cents, like so. I'm running out of room, but C equals 0.55 times by S plus small c to represent that constant, and I might erase that now because I've run out of space. Okay, so using that, subbing one of those points, so 6, $5.30 into there. So we have $5.30 equals 0.55 times by S plus C. Sorry, not times by S because we know what that is. Times by 6. Okay, now I'll use my calculator to help me here, so I have it correct. Times by 6. That's $3.30. $30 plus C. So I have to subtract both sides by $3.30. So that gives me $2. And so C equals 0.55 times by S plus $2. Now you could just write 2 there, but as we're dealing with money, I tend to leave it to 2 decimal places. So, next question. How much does it cost to produce a size 12 shoe? Okay, so here we get told that S equals 12. So, I've got to sub that in. So sub in S equals to 12. So C equals 0.55 times by 12. By the way, just a side note, I'm writing times by S here because my S's look a bit like 5s. So I'm just trying to make it a bit clear for everyone. Plus $2. So C equals 55. 0.55 times by 12, and that's $6.60. $60 plus $2, so C equals $8.60. So that cost $8.60.